Let's look at another example of the Bayes rule. We're going to look at the marketing tests. Say your company is developing a new product, and we want to predict whether the sales of this product is going to be high or low. And we're going to do it by taking inputs from the focus group. And then we will have a predictive model that is based on historical data. From the past experience, we know that positive, neutral, or negative reactions of the focus group actually do predict whether the sale is going to be high or low. So in essence, it's a similar approach that Netflix is using to predict whether the movie is going to be popular or not. So this is the setup for the problem. Suppose that we have prior probability for the product to have high sales to be equal to 8%. So let's start introducing notations. So we're going to use H for the high sales, and we know that probability that the sale is going to be high is 8%, and the rest of the time probability 92 that sales are low. And we also know the following things about the focus group, or we call it marketing test here, so essentially asking the focus group the opinion about the product. If sales are high, then consumer test reaction is positive in 70% of the cases. So in other words, for the product that had high sales, in 70% of the cases, there was a positive reaction to the product. And neutral reaction in 25% of the cases, so we have a neutral reaction for the high sales product in 25% of the cases. And the rest of the time, 5%, people reacted negatively to the product that had high sales. Okay, and we have the same numbers for the low sales product. So this is for the high, and the same numbers for the low. We have 0.15, 0.35, and 0.5, which makes sense. So the product that had low sales had negative reaction in 50% of the cases. What essentially we are interested in, so we want to calculate probability that the product will have high sales given the reaction of the focus group. So let's say the focus group had a positive reaction, and we want to predict what will be the whether the sale is going to be high or low. And again, so you see we have inverse of that. We have probability of seeing positive reaction given the high sales, and we're just going to use the Bayes rule to calculate the quantity of interest, which is this one. Okay, so we did set up the problem already: high sales, low sales, positive, negative, and neutral reactions. We were given certain conditional probabilities, and we were given the priors about the high and low sales. And now let's apply the Bayes rule to calculate the quantity that we're interested in. So we're interested in describing the posterior probability that the product will have high sales. Let's say the reaction was positive of the focus group. And you remember for this, we need to, so if we just apply the Bayes rule, it's a probability of seeing positive reaction given the product had high sales times the probability of seeing positive, seeing high sales, the prior probability of high sales, divided by the probability of seeing positive reaction. And this one is given to us already. I think this one was 0.7. So this one is 0.7. This one was given to us. We know that the prior probability is 8%, 0.08. So we need to calculate the total probability, and the total probability of seeing the positive reaction is sum of probability of seeing positive reaction for the highest sales product times probability of high sales plus the probability of seeing positive reaction on the low sales scenario times the probability of the low sales. So again, all of those quantities are given to us. We calculate 0.94 here, 0.194, and now we can calculate the final answer. If we plug in all of those numbers into the equation, we get roughly 30% chance that the product will have high sales given the direction of the focus group was positive. And again, the reason is, you remember we started, so again, so what we started here, we started with a prior, P of H being equal 0.08. So we have a new product, we don't know anything about this product. And if we asked what would be the probability of this product being popular, having high sales, we say, okay, 8%. And now what happens, we do the focus group, so we collect a new piece of evidence, a new piece of information about this product. And the focus group tells us that it's positive, so that's our data. So that's the data, and that's our prior. And the Bayes rule allows us to combine the prior information and the data to calculate the posterior probability of the product to have high sales. And again, it went up. This reflects how we update our probability about seeing high sales for this specific product. Okay, so let's look at another example. Two-headed coins. We have a large jar. It contains 1,024 coins, and one of the coins is two-headed coin. So we have 1,024 total coins. You pick at random a coin and flip it 10 times, and you get all heads. So you have 1,024 fair coins plus one two-headed coins. So this is two-headed, this is fair coins. And you flip it 10 times and you observe, you randomly pick a coin, observe 10 heads. Okay, so what's the probability that the coin is a two-headed coin that you picked from the jar? Well, the prior probability, so you remember we picked randomly, so the prior probability of picking a two-headed coin is very low. So prior was probability of two-headed coin. You remember there is only 1 out of 1,025. So it's a very low, very low number. Okay. Now what we're interested in posterior, because we collected some data. So we want to know what's the probability of observing two-headed coin, given that we saw 10 heads. So we collected some data about this coin. Now we want to update our probability about what type of coin it is. And so we can do it in a formal Bayesian rule way, right? So it's going to be a probability of seeing 10 heads, given it's a two-headed coin, times the prior probability of picking two-headed coin divided by the probability of observing 10 heads. Okay, well, this one we know. Probability of observing 10 heads given it's a 10-headed coin is 1, right? Because 10-headed coin always will end up on a tail, on a head, sorry. And probability of two-headed coin is, we calculate this, 1 over 1,025. So now we need to calculate probability of observing 10 heads. Well, there are two scenarios, right? So probability of observing 10-headed coin is the probability of observing, this is probability of observing 10 heads. It's a probability of observing 10 heads, given that we have two-headed coin, times the probability of two-headed coin, plus the probability of observing 10 heads, given the fair coin, times the probability of fair coin. Well, and if you work it out, you actually have the posterior probability to be equal to 1/2 roughly. Okay. Yeah, so here are the calculations, right? So that's the probability of observing 10 heads, given that it's a two-headed coin, times the prior probability of picking up a two-headed coin, and this is the total probability of observing 10 heads. And so if you work out the probabilities, you get 50-50 chance. So again, here, you remember our prior probability of two-headed coin was 1 over 1025. So it's a very low chance of picking randomly two-headed coin. But then once we collected evidence, then probability of two-headed coin, given the evidence that we saw 10 heads, is actually 0.5. So we went from very low probability to relatively high probability, 50-50% chance, just because evidence is so strong. If you think about this, probability of observing 10 heads on the assumption that it's a fair coin is very low. So when you see such an evidence, it's a very strong evidence that it is indeed